Okay, now we see how to identify the hybridization of carbon and carbon compounds. So simply we know that carbon generally forms only 4 bonds. It contains maybe some sigma bonds and pi bonds, but whatever it is, in the carbon compounds, we just use to calculate the number of sigma bonds. If number of sigma bonds of a carbon is equal to 2, that is sp hybridization. Same if number of sigma bonds of carbon and a compound is 3, that is sp2. If the number of sigma bonds of that carbon is equal to 4, that is sp3 hybridization. Means here important is carbon can form only 4 bonds. Means the hybridization is limited up to sp3. Means carbon can form sp hybridization, sp2 hybridization and sp3 hybridization. There is no possibility of other hybridizations because carbon can form only 4 bonds. If 4 sigma bonds, that is sp3. If the 3 sigma bonds on it, the remaining one will be pi bond, sp2. The carbon having only 2 sigma bonds, that is sp hybridization. Okay, now we see some examples based on this. For example, methane. So methane having 4 sigma bonds. The carbon in methane, carbon is having 4 sigma bonds. 4 sigma bond that indicates sp3. And we take another compound C2H6. Here thing is we need to give its normal structure. So C2H6 we can written as CH3 and CH3. We can expand this CH3 bond CH3 like this. Carbon must possess 4 bonds. So this is CH3, CH3 2 ports connected by 1 bond. Here this carbon is having this is 1, 2, 3, 4 sigma bonds. 4 sigma means that is sp3 hybridization. So this carbon is also having 1, 2, 3, 4 sigma bonds. So therefore it also undergoes sp3 hybridization. Here both carbons undergoes sp3 hybridization. It is not compulsory always that all carbons must possess same hybridization in a compound. Okay. See the other one. C2H4. It can be written as C2H4 means it is like this. We are not giving the proper structure, just we are calculating the hybridization in it. So what is the carbon sigma bonds? This is one sigma bond, second sigma bond. In these two covalent bonds, one is only sigma bond, the remaining one is always pi bond. Means between two carbon atoms, not only carbon atoms, between any two atoms there is only formation of one sigma bond. Means this carbon is having 3 sigma bonds. Just leave the pi bond. There is no necessary for counting the pi bond. 3 sigma bonds indicates sp2. So this is also having 1, 2, 3 sigma bonds. It also undergoing sp2 hybridization. Now we will check the hybridization of carbon in some more compounds. Acetylene C2H2, so it can be written as C2H2. Carbon must possess 4 bonds and it should satisfy this formula. So this carbon is having how many sigma bonds around it? This 1, 2. Here 3 bonds are present. In the 3 bonds only one is sigma. Here 1 sigma, here 1 sigma. This carbon is having 2 sigma bonds. That is only sp hybridization. In the same way, this is also having 2 sigma bonds and undergoing sp hybridization. Now we see some compounds in which the carbon is undergoing different hybridizations. For example, we are taking this an organic compound. So we need to identify the hybridization of all these carbons. So what is this carbon hybridization? So For this example, we are expanding this total structure. So this can be written as CH3, CH2, CH and CH2. No bother about the direction of hydrogens here. So this carbon undergoes 1, 2, 3, 4 sigma bonds. So it is sp3 hybridization. So this carbon is also having 4 sigma bonds around it, sp3 hybridization, whereas this carbon is having 1, 2, 3. In these two bonds only 1 sigma. Total 3 sigmas, it is sp2. Here also 1, 2, 3, 3 sigmas, sp2s. Means in these 4 carbons, 2 carbons are undergoing sp3 hybridization, other 2 are undergoing sp2 hybridization. The first 2 carbons undergoing sp3, other 2 are undergoing sp2 hybridization. So it is always no need to write the total expansion of the structure. We see other example also like that. Now we are taking a compound having 5 carbons. So here, how many sigma bonds are present on this carbon? So number of sigma bond we can calculate. Between 2 carbons, 1 sigma bond must be there, and it is having 3 hydrogens. The hydrogens bonded with carbon by only sigma bond. Means the number of hydrogens are nothing but equal to they undergoes only sigma bonds. And there is one another bond with the next carbon, means total here 4 sigma bonds, sp3. Now about this, so this is having no hydrogens, but is having 1 carbon left side, 1 carbon right side, 2 sigmas, it is sp hybridization. See this one, this is also having 1 front side and back side, 2 sigma bonds, remaining here 2 are triple bond, the 2 are pi bonds. The middle of any one, the one is a sigma bond. Here totally 2 sigma bonds, that is sp. And here absorb 1 hydrogen, means nothing but 1 sigma bond. From front carbon and back carbon, total 3 sigmas are there, sp2. Whereas this here having 2 hydrogens, nothing but 2 sigma bonds. And in these 2 bonds, one is compulsory sigma bond, total 3 sigma bonds. It is sp2 hybridizations. So like this, the carbon having only 3 type of hybridization, sp, sp2, sp3. And now we see some more examples. Also in acetic acid. So in acetic acid, the structure is like this. So what about this carbon? This carbon is having how many sigma bonds? It's 4 sigma bonds. So it is sp3 hybridization. Whereas this carbon is having 1, 2, in these 2 bonds, only 1 sigma bond is always. It is having 3 sigmas, that is sp2. Means in this compound, only 2 carbons are there. The 2 carbons are having different hybridizations. Okay. We can calculate in aldehyde groups. It's called ethanol. Here also same thing takes place. This carbon is having 1, 2, 3, 4, 4 sigma bonds, sp3, and this carbon is having 1, 2, 3 sigma bonds. Remaining one will be pi bond. It is not in the calculation. 3 sigma bonds, that is only sp2. So this is to calculate the hybridization of carbon in carbon compounds mainly. Okay.